We are in Chapter 3, Describing, Exploring, and Comparing Data. Section 3.1 is Measures of Center. Measures of center is a value at the center or the middle of the data set. We have one way of discussing that is using a mean or an arithmetic mean. Is the measure of center found by adding up all the observations in a data set and dividing by the number of observations that we have. We have a population mean and a sample mean. And the difference that you guys need to know for these is that for the population mean, we use a mu, and for a sample mean, we use an x bar. They are calculated identically. However, for a population mean, we will be using the population size, capital N, and the sample will be using just a sample size, which is lowercase n. The symbol sigma is a Greek letter, and it tells us to add up all the terms together. Resistant is a statistic is resistant if the presence of an extreme value or an outlier does not cause it to change very much. Important properties of the mean. Just one extreme value can change the value of the mean substantially. The first example that we have says the data below represents the miles traveled to work by 10 employees at a local ice cream shop. They are 23, 12, 15, 8, 20, 11, 12, 5, 18, and 10 miles. So to compute the population mean, which is what we first are doing in Part A, we need to add up all those numbers and divide by the total that we have, which is 10 employees. To symbolize a population mean, we use that symbol mu. And so if we take those values, add them all up and divide by 10, we get 13.4. And the units that go with this are the units that we're discussing here, which is miles. Part B says to find a simple random sample of size n equals 4. And so you could pick any of those 4 employees randomly. For sake of us all doing the same problem, I'm going to select for us 8, 12, 18, and 5 miles. So Part C says to compute the sample mean of the sample found in Part B. So the symbol that we use for a sample is going to be x bar to represent the mean. And so to do this, we're going to add up those 4 values that we have up above and divide by 4. When we do that, we get 10.75. And again, the units that we have is miles. And this would have been different if you had picked a different 4 employees in order to calculate that sample mean. Part D says a histogram is created below. Where is the population mean? So the histogram is already created for us. That population mean, again, is 13.4. And it's somewhere in the middle over here. And I'm going to label it up above since I don't have any room down below. But if you notice, our frequency distribution is not finished. So looking at those, you can read your histogram and go backwards from that, or you can look at the data set that we have. But this is 1 person drives between 0 and 5 miles. 2 are between 6 and 10. 4 between 11 and 15. And then 2 between 16 and 20. And 1 between 21 and 25. The population mean is in the middle of the histogram's x values. And this distribution looks approximately bell-shaped. The next measure of center that we have is the median. It's denoted capital M of a variable is the measure of center, that is the value that lies in the middle of the data when the data has to be arranged in order. So you can put it in either smallest to largest or largest to smallest. So steps for finding the median: arrange the data in order, determine the number of observations, and then step 3 says determine the observation in the middle. If the middle consists of 2 numbers, then the median is going to be the mean of those 2 values. So the example on here says from the previous example, find the median of the miles traveled to work. So the first thing that we need to do is take our data values and we're going to put them in order. I'm going to go ahead and put them in order from smallest to largest. So the smallest value that we have is 5. And then 8, 10, 11. We have 2 people that drove 12 miles, so make sure you list them both. 15, and we have 18, 20, and 23. So putting them all in order again, checking to make sure we didn't forget anybody. And now we need to look at the middle value that we have. If you notice in this problem, we actually have two middle values. And so in order to find our median, which we symbolize by a capital M, I'm going to add together those two values and divide by 2. And that is just going to equal 12. And again, the units that we use for this would be exactly the same units that we're talking about, which is miles. So the median is 12 miles. So we have a graphing calculator that we use for this class, and I am going to be using a TI 83 or 84 calculator. There are apps that you can use for either an Apple or an Android device. You can also download different emulators on your computer, and then you can also purchase a TI 83 or 84 calculator. So in order to calculate the mean and the median with using a calculator, we're going to go to Stat, Edit, Enter. You're going to input your data into L1, and then you're going to go to Stat, Calc, go to 1var Stats, and press Enter twice. These boxes that are around these words that are on here are the buttons that are represented on your calculator. And X bar is going to be the mean. That's going to be for the population and for the sample, depending on what kind of data you're dealing with. And MED is what the calculator used to represent median. So the next example says, using a graphing utility, find the mean and the median of the exam scores of the 15 students in an algebra course. The course scores are, and they're listed there. So first thing that you guys are going to have to do is take all of these numbers and input them into L1.
On your calculator, you want to go to Stat, to Edit, select Enter, and enter in all those exam scores into L1. This is raw data, or just a list of numbers. Next, we go to Stat, scroll over to Calc, to 1var Stats, select Enter. And for list, you need to have L1 typed here. If you do not, you're going to hit second, 1, and L1 should appear if that's where your list is. Frequency list needs to be blank. Calculate, select Enter. We get our mean, and our median is found by scrolling down, and MED is how the calculator represents median.
From the calculator, we see that we get X bar, our sample mean, is going to be 79.07, and our median, which I'm going to write as M, is going to be 80. And again, both of those are from the calculator. Important properties about the median. An extreme value does not change the median by a lot. If a large value is changed, the median would stay the same. And we can see that in the next example that we have. So the example says the data below represents the lengths and minutes of Jason's cell phone calls for the day. Find the mean and the median of the data and determine which measures of central tendency you think better describe the typical call length. So his call lengths are 3, 2, 1, 3, 1, 5, 4, 7, 5, and 52 minutes. So we're going to take all these numbers, enter them into L1, and we're going to get the mean for the data and the median for the data. From the calculator, we get that the mean is equal to 8.3 minutes and that the median is equal to 3.5 minutes. The median better just demonstrates the typical call length. The 52-minute phone call is an extreme observation and causes the mean to increase substantially and has no effect on the median. So his phone calls are relatively short. Most of them are under 5 minutes. And so 3.5 represents the average or the amount of time he spends on a phone call. For example, if the 52-minute phone call was 8 minutes instead, then our mean would change substantially, but our median stays the same. And similarly, if that 52-minute phone call was even longer, say 152 minutes instead, our mean would change even more, but the median would stay the same. Mode is the most frequent observation of the data set, and it can be either quantitative or qualitative. We have a few different situations that arise with the mode, and so sometimes we do have a case where there is no mode. An example of this would be when you guys have numbers such as 1, 7, 3, and 9. Those values, none of them repeat. They all occur the same amount of time, just once. So this is an example of no mode. Multiple modes are going to be where multiple data values repeat the same number of times. So for example here, we would have something like 2, 4, 4, 2, and 7. And from this, you'll notice that 2 and 4 both repeat twice. So we would have two modes. They would be 2 and 4. Important properties about the mode. We can find the mode of qualitative data. So there's two examples below. One is of qualitative data and one is of quantitative data. The first example here says find the mode of the data set above in regards to the miles driven to work. 23, 12, 15, 8, 20, 11, 12, 5, 18, and 10. The mode here is going to be 12. And the reason why this is the mode is because the number 12 is occurring the most, and it occurs twice. And so that is the most that any of these numbers occur for the miles driven to work. The next example says the table below lists the color of cars driven by 12 college students. Determine the mode color of car. So carefully looking at those, you will notice that this one actually has two modes. I'm going to go ahead and put a B for black and a W for white. So yes, both black and white are the mode. And the reason why is because they both occur, and they both are occurring the same amount of times, and they both occur 3 times. And that's the most out of all those colors. The next definition that we have is called the mid-range. The mid-range of a data set is the measure of center, that is the value midway between the maximum and minimum values of the data set. And so the mid-range, you are going to take your max value and we're going to add it with the minimum data value, the smallest value that you have, and we are going to divide by 2. Important properties about the mid-range: it's very sensitive to extreme values. The next example we have says find the mid-range of the Verizon data speeds, and we have 38.5, 55.6, 22.4, 14.1, and 23.1. And these are all in megabits per second. So in order to find our mid-range, we need to add up the max value that we have, which is 55.6, and our minimum value that we have, which is the smallest number, which is 14.1. And once we have those added up together, we're going to divide that by 2. And doing that, we get 34.85. And again, those units will stay exactly the same. So we're going to have megabits per second. So rounding rules for the measures of center. For the mean, median, and mid-range, carry one more decimal place than is present in the original set of values. And for the mode, leave the value as it is without rounding. Again, for you guys, it's mostly done with MyOpenMath. And with MyOpenMath, they will clearly communicate to you guys how to round. And if you are dealing with something that is written, I will clearly communicate to you guys how to round also. The next definition we have is grouped data. When data is summarized in a frequency distribution, we cannot find exact values of the mean or the standard deviation, which was discussed in section 3.2. However, we can approximate these measures. So approximate the mean of a variable from a frequency distribution. We are going to multiply x times f, which is going to be our midpoints and our frequency. And then we're going to divide by the total frequency that we have. The steps to do this with a graphing calculator is going to be, we're going to go to Stat, to Edit. L1 is going to be our class midpoints, and L2 is going to be our frequencies or relative frequencies. And then the next thing we're going to do is go to Stat. You're going to scroll over to Calc. You're going to go to 1 var stats and hit enter. If you have a TI-83, which is the older style graphing calculators, you'll be entering in your information just as it is written here. So second 1, comma, second 2. And so on the home screen, it should say 1 var stats L1, comma, L2. If you have a newer style calculator, you will notice that when you go to 1 var stats, it's actually going to prompt you for some information. First thing it's going to ask you is, what is the list? And the list for this is going to be your class midpoints, which is listed in L1. And then it's also going to ask you guys for the frequency list. And the frequency list is going to be either your frequencies or your relative frequencies, which are in L2. And then the next thing on there should be the word calculate. And you want to just go down and hit enter on calculate. The output, though, will be the same for everybody. So we have SX, which is the approximation standard deviation that we have for the sample. X bar is your approximate sample mean. Sigma X is the population standard deviation. And again, that's an approximation that we would have. So the next example that we have says the data represents SAT mathematics scores for 2010. Find the approximate mean of the data. And the reason why it's again approximate is because this is grouped data. We do not know exactly how many people scored a 550 on these SATs. We do know that 467,855 people scored between 500 and 599. So since we are dealing with grouped data, the first thing that we need to calculate is our midpoints. And so midpoints are going to be calculated by adding your lower bound and your upper bound together and then dividing by 2. So for the first one, you should get 249.5. So take a second to calculate the rest of these. So we should arrive at the same midpoints that I have listed on here. So the next thing that we need to do is we need to put our data into our calculator. The midpoints again go into L1. And then your frequency, which for this case is the number of people, is going to go into L2.
On your calculator, you're going to go to Stat, to Edit, and enter in the values we have into L1, which is our midpoints, and L2, which is our frequencies. Then we're going to go to Stat, scroll over to Calc, and select Enter on 1 var stats. L1 is our list, and our frequency list is set into L2. So go ahead and hit second, 2, and an L2 should appear there. Scroll down to calculate, select enter, and we get our mean.
So from the calculator, we get our mean is going to be 519.74. And on the calculator, you are actually looking at X bar. However, this following data is representing mathematics scores for 2010. This is everybody. And since we're dealing with everybody, we're actually talking about a population. So I am going to need to make sure I use the correct terminology and the correct symbols. And for this one, it would be a mu. So go ahead and put mu in. The next thing that we have is a weighted mean. And this is denoted X bar. It's an average in which each quantity to be averaged is assigned different weights, W. These weightings are determining the relative importance of each quantity on average. In other words, a mean where some values contribute more than others. So there's a formula there to calculate the weighted average or the weighted mean. And there's an example right below it that I'm going to circle, and we will look at that together in class. The next section is 3.2, which is measures of variation. Measures of variation are used to quantify the spread of data. Numerical measures for describing the dispersion or the spread of data in this section are range, standard deviation, and variance. The range is denoted capital R of a variable is the difference between the largest data value and the smallest data value. So we are going to subtract those. Important properties about the range. It's very sensitive to extreme values. So the example right below that says from the miles traveled to work, compute the range. And so the largest data value that we have is 23. And the smallest data value that we have is 5. And so the range, we're going to subtract those, and 23 minus 5 is 18. And we're going to go ahead and put the word miles in here, since that was what our units are that we were talking about. The big one that we have that's going to carry through for the rest of the semester is called standard deviation. This is a statistic and tells you how close all various data points are clustered around the mean. If the data points of a set vary greatly from the mean, they're more dispersed, then standard deviation will be large. If the data points of a set are varied only slightly from the mean, then the standard deviation will be very small. So there's some pictures down below. You can see that the first one is where they are clustered pretty close around the mean. You also notice that we have a bell-shaped curve that we'll get more into in a little bit. So the second picture that we have here, you will notice that we have more dispersed data sets, and your bell-shaped curve is more spread out. That has a larger standard deviation. So we have a population standard deviation and a sample standard deviation. For the population standard deviation, we use sigma, and the sample standard deviation, we use an S. And they are the measure of how much data values deviate away from the population mean or the sample mean. We have two different formulas to calculate the standard deviation of a sample. The formulas are similar for a population except for dividing by capital N instead of n-1. We will not be calculating the standard deviation by hand. Instead, we'll be computing it by using the graphing calculator. Important properties about standard deviation. It's not negative. Larger values indicate greater variation. The units are the same as the original data. So the next example that we have says the following frequency distribution represents the number of live births in thousands in the U.S. in 2008 by age of mother. Determine the population mean and the standard deviation for the data. And again, this is everybody in 2008, so we are dealing with the population. This is another example of grouped data. Since we're dealing with grouped data, we will need to calculate those midpoints. Again, a midpoint is found by adding the lower and the upper bounds for your class and then dividing by 2. So the first midpoint that we have, we are going to add 10 and 14 together and divide by 2, and we get 12. So go ahead and see if you can calculate the remaining midpoints for this data set. So you should have the following midpoints, and these midpoints need to be entered in on our calculator. Again, midpoints are going to go in L1. And then our frequency, and in this case we are dealing with births, is going to go into L2. It does say thousands, but that's just talking about these numbers all the same. And you're just going to enter these in and not put down the zeros that go along with them.
On your calculator, you are going to go to Stat, to Edit, select Enter, and then enter in your values into L1 and L2. Again, L1 is your midpoints for the class, and L2 is your frequencies for that group. Next, go to Stat, Calc, 1var Stats, select Enter. Since we are dealing with grouped data, you need to have L1 in your list, and you need to have L2 where you have your frequencies in frequency list. Scroll down to Calculate, select Enter, and we have X bar, which stands for the mean for the problem.
From the calculator, we get our mean, which is mu, is equal to 27.37, and our standard deviation, which is sigma, is equal to 6.28. The units for both of these are in years. So I'm going to go ahead and write years for both. So years. The next thing right below this is the range rule of thumb for identifying a significant value. So our values that are not significant are centered around the mean, which I'm going to go ahead and use mu. We're going to go out 1 and then 2 standard deviations both ways. And values that are not significant are going to be within the mean minus 2 standard deviations, and then the mean plus 2 standard deviations. Those values are not significant. Values that are significantly low are values that are smaller than mu minus 2 sigma, and values that are significantly high are values that are mu plus 2 sigma or larger. Variance, or a set of values, is a measure of variation equal to the square of the standard deviation. The population variance is sigma squared, and the sample variance is s squared. You can take your standard deviation value that you get on your calculator and square it to get the variance. Important properties about the variance: units are square units of the original data. On the next page, we have the empirical rule. It says if a distribution is roughly bell-shaped, then approximately 68% of the data will lie within 1 standard deviation, so mu plus and minus 1 sigma. Approximately 95% of the data will lie within 2 standard deviations of the mean, and approximately 99.7% of the sample data will lie within 3 standard deviations of the mean. And the empirical rule is the same based on sample data, with x bar used instead of mu, and s replaces sigma. Those percentages also would hold true for that, for the empirical rule.